Okay, on question number 6, we want to find the inverse Laplace transform of 5 over s minus 4 to the third. So again, we can use the table of Laplace transforms, and if I look on my right side, I don't see anything exactly like this, but I do know that the s minus 4 to the third, that s minus 4, can be thought of as a shift. So this is our first shifting theorem, and it tells me that I can pull out an exponential e to the at, where in this case a is 4, so I get e to the 4t, and then I shift that s minus 4 back to just an s, and then find the inverse Laplace transform of 5 over s to the third. So the inverse transform of 5 over s to the third, that's this Laplace of t to the n transform. Not sure why I had that copied, but here we go. Where n is 2, 2 plus 1 gives me 3s to the third. And because n is 2, I need a 2 factorial at the top. And so 2 factorial is 2 times 1, which is just 2. I have a 5 here, so I'm going to replace the 5 with the 2. That's going to bring the 5 here in front, and then I'll divide by 2 to balance out the 2 that I'm putting in. So there I'm balancing out the 2. I put that as 2 factorial, so it looked like my n factorial. And the inverse Laplace transform of 2 factorial over s to the third is t to the second. Gives me e to the 4t times 5 halves, t to the second. Typically, you see the exponential last, like this, but however you want to write it. The answer is 5 halves t squared e to the 4t.